Dryness Level 1. At this stage, cross water has been effectively removed from the surface. However, traces of moisture may still remain. The first stage of the dryness procedure involves a series of pneumatic blows designed to remove any potential water slugs from the pipework. Typically, nitrogen is used throughout the drying process due to its exceptionally low dew point, ensuring effective dryness. In some cases, air may be used as an alternative. However, it must be thoroughly filtered, dry, and oil-free to meet the necessary standards. Before any drying procedure begins, it is essential to test the dew point of the air supply to ensure it is at or below -30 degrees Celsius. This guarantees the air is suitably dry for the process. Once verified, the drying medium is connected to an appropriate point in the system to commence the procedure. When preparing for pneumatic blowing, consider the system's design pressure. The pipework and vessels should be pressurized to approximately 25 sig. However, if the system's design pressure is lower, use an appropriate and safe pressure for the operation. Be sure to follow the detailed guidelines provided in the Cleaning by Pneumatic Blowing section for best practices. To ensure safety during the process, all personnel must be kept out of the area. Barriers and warning signs should be erected, and all operations and construction staff must be informed about the ongoing activity. Begin by depressurizing the system at a suitable low-point valve and inspecting for any evidence of water. Continue blowing at the low points until no water or mist is visible in the exhaust gas. Once the blowdown step is complete, proceed to the stage by continuously blowing the system. Open the drying source and purge the system from as many low points as possible to ensure thorough drying. Ensure if nitrogen is being used that any outlets cannot allow the collection of nitrogen gas in enclosed or confined spaces. Be aware of the source of the drying media and liaise with the controller of the source to ensure no other user is being depleted by the drying operation. Continue purging the system for approximately 12 hours. After this period, take a sample from a low-point purge using a dew point meter to measure moisture levels. If the reading exceeds -30 degrees Celsius, maintain the purge until the moisture level drops. Once the dew point reading reaches -30 degrees Celsius or lower, discontinue the purge and proceed to reinstate the system. Purge times can be significantly lowered if it is possible to heat the source with an external electric or steam heater, or by warming process vessels with the heat source. This secondary level of dryness is crucial for refrigeration systems, process applications, or situations where zero moisture is acceptable. Achieving this level involves creating a full vacuum within the system. However, this process has significant implications. When drafting the evacuation procedure, conduct a comprehensive check of all pipes, vessels, equipment, instruments, and relief streams to confirm their ability to withstand a full vacuum. Notably, some instruments may not be rated for full vacuum conditions. In such cases, they should be properly isolated. Ensure all isolations are documented and aligned with the evacuation procedure to maintain system integrity. For any application, the initial step in achieving dryness level 2 is to first complete all steps outlined in dryness level 1. Once dryness level 1 is successfully accomplished, the next step involves connecting an evacuation pump to the system to proceed with the additional drying requirements. Ensure a calibrated vacuum gauge is fitted to a suitable position where it can be easily read. Do not fit the gauge in a location that it is closed off when isolating the vacuum pump. Valve up the system accordingly so all sections can be fully evacuated. Start the vacuum pump. Monitor the vacuum pump oil. If it goes milky, moisture is present and the oil will need to be changed, and 2. The exhaust from the pump. A mist will indicate moisture. On a dry, leak-tight system, the pressure should fall very quickly. If it does not and mist is seen at the evacuation pump, there is air being drawn into the system and a secondary leak test must be conducted. Continue to run the vacuum pump until desired vacuum pressure is seen on the gauge. and there is no sign of discolored oil or exhaust fumes from the evacuation pump. Stop the vacuum pump and disconnect from the pipework. Begin to monitor the vacuum gauge. If the pressure rises, then the system is leaking and a leak test must again be conducted. If the pressure holds, a full vacuum has been pulled and the system will be dry. Attach a nitrogen source and break the vacuum by pressuring to atmospheric pressure with nitrogen. If required, break the vacuum with process gases. Remove all evacuation equipment and make good for continued commissioning.